My name is Birabak. I'm going to talk about the final learning reflection of Internet of Things, named IoT. This is the agenda in my final learning reflection, what I learned in this program, the roadblock I made, what I'm going to do next. After learning about things for the IoT platform and MQTT IoT protocol, we start to learn DigStack. The DigStack is a powerful IoT data monitoring tool with a detailed dashboard to make a collection, storage, graphing, and alerting on time series data easy. There are three elements of DigStack. DigStack stands for Telegraph, InfluxDB, and Grafana. Telegraph is a metric collection agent for collecting time series data from IoT devices. InfluxDB is a high-performance time series database. It is a kind of a dashboard, queries, tasks, and agent all in one place. Grafana is an open-source platform for data visualization, monitoring, and analysis. In the class, we used the Docker Compose file for easy deployment. Because the Docker Compose file enables us to run these different containers. Instead of firing up all containers individually with the respective configuration, we can write a script which does this for us. YAML file is used to configure our application service. Then with a single command, we create and start all three services from our configuration. A new trend of IoT platform is IoT cloud service. An IoT cloud is a massive network that supports IoT devices and applications. This includes the underlying infrastructure, servers, and storage needed for real-time operation and processing. We had studied IoT cloud service using AWS Cloud Service. AWS IoT Cloud Service enables us to connect IoT devices easily and securely, interact with the cloud application and other devices. My final demo is to connect between Raspberry Pi and AWS Cloud Service for collecting and utilizing the data from the sense of Pi. This is the 5 step in my final demonstration, how to connect to Raspberry Pi to AWS IoT and push the data into the DynamoDB application. Number 1. Registering my Raspberry Pi to AWS, creating and setting up certificate. Number 2. Create a Python code and configure AWS certificate to connect in the Raspberry Pi. Number 3. Testing the Python code for subscribing and publishing the data of a Pi sensor. Number 4. AWS policy creation and association. Number 5. Creating DynamoDB rule and DynamoDB table. From the final demonstration, I understand how AWS IoT works and what I need to practice the skill of IoT cloud service in the future. Matter is an emerging smart home IoT protocol. Matter will enable IP-based networking between both smart home devices and the smartphone application or cloud service that make those devices useful. The goal of Matter is going to be an IoT standard protocol so that smartphone devices can work across different ecosystems. I found there still not much new technology involved in getting this Matter protocol live. So I think there is a lot of room to study Matter in the future. Finally, we studied the IoT security fallacy. This class was a time to think about what the vulnerability of IoT are and how to prevent them. Due to the characteristic of IoT applications suffer from various vulnerabilities, such as weak and hard-coded password, lack of the update process or mechanism, unsecured network service, outdated or unsecured IoT application component, unsecured data storage and transfer. It is very imperative that to prevent those vulnerabilities, we should prepare IoT security policy and plan, because this is not just one activity of protecting IoT application. There are two node blocks I made in this class. First, I tried to set up the tech stack on the Ubuntu virtual machine using the Docker compose file, because it is a simple and fast way to create it. However, I did not get it because I made some error when I learned the Docker compose file. I knew there are some other way to set up the tech stack, and someday I will try to set up the tech stack again. Second, when I choose AWS IoT project for the final demonstration, AWS IoT Analytics is my first option to collect and visualize the data of sensors. But AWS does not provide AWS IoT Analytics service in Canada zone. So I have to choose other option, DynamoDB, to utilize the data. What I'm going to do next, when I did my final demonstration project, I felt very sorry because I'm not able to use AWS IoT Analytics service to collect and visualize the data of sensors. I would like to create a high-level AWS IoT Analytics platform to utilize the data and visualize them for user by changing AWS service region. Thank you, Nola.